Alright, today we're going to talk about surface area, and the definition is the outside area of a three-dimensional surface. So think of it as if you're going to paint the walls on your house on the outside, or even on the inside, doesn't matter. We're just talking about overall, if we have a bunch of surfaces that form a figure, what would be the area of all those figures combined? Which leads us into the two different options for calculating it. So one thing that you can do is unfold the object, add up the areas of each piece, and you'll get your total surface area. Now you don't have to actually unfold it, you can just visualize and see, okay, here are my pieces, and then make some calculations. I'll show you how to do that. I'll also show you how to use this formula, which looks long and complicated, but it's actually very easy. You figure out what your base of that prism is. We're talking about prisms here, so I guess this is the formula for prisms. Okay, and you take the perimeter of your base times the height plus twice the base area. So I'll show you both of these. Now let's take a look at then, excuse me, this figure right here. We have a rectangular prism, and right off the bat I'm going to show you how the formula works. So for a prism, we can take perimeter of base times the height of our figure plus twice the base area. Okay. Now, remember the base doesn't always have to be the thing that's on the ground, but in this instance, I will make this bottom rectangle our base, which is also on the top the same rectangle. Remember that the base is the figure that makes your shape unique. So anyway, the first thing we need to figure out then would be the perimeter of that base, which would be the distance around the base. Well, if I was looking at this over the top, I would see this, and I would have a 5, 5, 2, 2. All right, now just add up all those. If we look at it this way, I got 7 plus 7, which is 14. So that's just for visual purposes. You don't always have to do that, but remember, perimeter talks about the distance around that shape. All right, the height is the distance between our two bases. In this instance, it does happen to be the vertical line between our two base rectangles. So times 20. And then our base area. Our base area, again, so everything revolves around the base. We have a rectangle, and it is a 2 by 5 rectangle. So 2 times 5 would give me my base area, which is 10. All right. So then we just got to add on, or add up everything, do these little calculations. So 14 times 20 is the first thing we're going to do, and this comes out to 280. And then we've got 20. Add these together, looks like we get 300, and what was our, inches, okay, 300 square inches. The total surface area. Alright. Now let's double check this answer by doing it the other way, taking it piece by piece. Alright, so that would be using the formula. That is available to 7th graders on the MCA formula sheets. 8th grade, you do not have that available to you, but not a big deal because surface area can be found this way as well. We're going to leave the answer there and make sure this works out. Let's look at all of our rectangles. Let's start with this bottom one, the base, since we already worked with it. We have 2 of these. We got one on bottom and one on top. Okay, so we have a 2 by 5 rectangle. And how many of those do we have? We've got 2 of them. So really we've got 10 times 2, or 20 square inches. Okay, let's find 2 other rectangles in here that are the same. There are 3 pairs. We got the 2 sides. What are those? Those are, what are those? Yeah, and I bet a lot of you picked up on that. My favorite saying, sarcasm. Okay, so we have a 2 by 20 rectangle. How many of those do we have? We've got 2 of them. So 2 times 20 is 40, times 2 gives me 80 square last two rectangles, we have a front and a back. So this, and then the one in back there. My scribbles are all making sense, right? So we got a 5 by 20 rectangle. We do have two of them. So this is 100 times 2.